two or more fractions are said to be equivalent if they represent the same value. In this video, I'm going to use simple diagrams to illustrate equivalent fractions. Now let us consider a fraction such as 8 over 24. Now remember that the value of a fraction remains the same if the numerator and the denominator are divided by the same number. So we're going to divide 8 over 24 by 2, and then it means that we're going to have 8 divided by 2 over 24 divided by 2, and this is equal to 4 over 12. Okay. Now, if now we decide to divide the numerator and the denominator by 4, now we're going to obtain 8 over 24 is equal to 8 divided by 4 over 24 divided by 4, and that is equal to 2 over 6. Okay, and then this time around we decide to divide both the numerator and the denominator by 8. We're going to have 8 over 24 is 8 divided by 8 over 24 divided by 8, and that's equal to 1 over 3. This means that the fractions, these ones, 8 over 24, and then 4 over 12, and then 2 over 6, and then 1 over 3 are all equal, which is to say that 8 over 24 is equal to 4 over 12 is equal to 2 over 6, and this is equal to 1 over 3. Now when fractions are equal in this way, they are called equivalent fractions. Equivalent fractions look different structurally, but they are the same in value. Now let us consider the following diagrams. They are all rectangles, and each rectangle has been divided into a number of equal parts, with some parts shaded. Okay. Now in each diagram we have in this one we have 1, 2, 3, 4, 5, 6. That's the rectangle has been divided into 12 equal parts, out of which 6 parts are shaded. So the fraction of the shaded portion is 6 over 12. Here the fraction of the shaded portion is 5 over 10. Here the fraction of the shaded portion is 4 over 8. Here the fraction of the shaded portion is 3 over 6, and here it is 2 over 4. Okay. Now notice that all the rectangles are of the same size, that is, they are all equal, and then all the shaded portions are also of the same size, and in each case the shaded portion is equal to half of the whole rectangle. That is to say that this shaded portion is half, this is half, this is half, this is half, and this is half of the entire rectangle. Now this can also be seen by comparing the numerator and the denominator of each of the fractions representing the shaded portions. Now in this case we have 6 over 12, 6 is half of 12. Here we have 5 over 10, 5 is half of 10. Here we have 4 over 8, and 4 is half of 8. Here 3 over 6, 3 is half of 6. And then here we have 2 over 4, and 2 of course is half of 4. Now this means that these fractions, 6 over 12, 5 over 10, 4 over 8, 3 over 6, and 2 over 4 represent the same amount, which is half of the whole rectangle, and therefore they are said to be equivalent fraction. Now that means that it means 6 over 12 is equal to 5 over 10 is equal to 4 over 8 is equal to 3 over 6 is equal to 2 over 4, and finally all these are equal to 1 over 2. So these are called equivalent fractions. Now we can identify a few other fractions that are equivalent to these ones. For example, 60 over 120, 50 over 100, 40 over 80, and so on. All these are equivalent to each other.